Do not build multi-agent systems. And here's why. So the multi-agent team is actually a trap. OpenAI and Microsoft want you to use their frameworks like OpenAI Swarm or Microsoft AutoGen to build teams of agents. However, Cognition AI just released an article that explains why building multi-agent systems is a trap and why you shouldn't do it. In this video, I'll reveal how agents like Devin are structured behind the scenes, plus what actually is the best and the most reliable way to build AI agents in 2025. So watch until the end. Now here is the article from Cognition, which I've sent to all of my friends who are building AI agents, called Don't Build Multi-Agents. And basically the article was written because the frameworks for LLM agents have been surprisingly disappointing. A year ago, we've all seen the hype around Crew AI, OpenAI Swarm, AutoGen, all the other frameworks, but how many of you are actually using software that's using these behind the scenes? Almost nobody. This perfectly matches my own experience of building Vectel, which is my AI startup, where we spent hundreds of hours making the agents more reliable, and what we found is that the more complexity you introduce, the more multi-agent systems you add, the lower the reliability is. And that's exactly what Walden, one of the co-founders of Cognition AI, the company behind Devin, explains in this article why most multi-agent systems do not work, and he gives two concrete examples of agentic systems that do work. Alright, so this is the article, Don't Build Multi-Agents. And the goal is to explain why some tempting ideas like having, hundreds of AI agents working underneath you are actually quite bad in practice. Now, unlike many other articles in the AI space, this one is actually quite easy to understand, and there are two main principles that it concludes with. Number one, share context. Number two, actions carry implicit decisions. And by the end of this video, you will understand why these two principles are absolutely essential if you want to build any serious AI agents. So why should we even think about principles? Well, this story of HTML is really good. So it was created in 1993. 20 years later, in 2013, Facebook released React. And nowadays, everything is built on top of React and other React frameworks like Next.js. So why is React such a dominant force? Well, because it's not just a scaffold for writing code, it's a philosophy of how you should build frontend. But this is the key. This was not always obvious to early web developers. And basically, in the age of LLMs, we are still playing with HTML and CSS. We are still at the very early steps of figuring out how to build these AI agents, let alone how to build multi-agent systems that are reliable. No single approach to building agents has become the standard yet. Now here is the dangerous trap. Libraries such as OpenAI Swarm or Microsoft AutoGen actively push people to build with multiple agentic systems, right? I mean, we can even click into some of these GitHub repos, right? The examples they will show you will be the simplest examples possible, but they will use like 5 different agents. This is exactly what I mean, right? Simplest example possible, but it's already encouraging people to build with multiple agents, even when the task is simple, which is a huge mistake. So as this article from Cognition AI says, this is the wrong way of building agents. Namely, that using multi-agent architectures is very, very risky unless you know what you're doing. By the way, if you're new to building AI agents, this article links two amazing resources, which I'm gonna quickly go over right now. Resource number one comes from Anthropic. So before we dive into the code, before I show you two bad approaches and two good approaches for building multi-agent systems, let's quickly look at these essential resources. First is the Building Effective Agents article from Anthropic that goes over the fundamentals. Basically, this article discourages against building complex AI agents. So it tries to make you build as simple and clear agents as possible. And it also warns against using frameworks, but more on that later. The second resource is from OpenAI. This article or PDF is a bit longer, it's like 20 to 30 pages, and it goes into tool calling, reasoning models, and guardrails. By the way, if you want to dive deeper into this OpenAI course, which takes like 7 hours to go through, I condensed it into a single 15-minute video, which you should watch after this video. Real quick, everyone who joins the new society during July will get a month of Vectel Pro for free. Plus, you'll get access to all the exclusive content we have inside, such as my startup journey where I documented going from zero to over $10,000 a month, and you can see all of it. But again, this offer is only available in July, so make sure to join the new society today. It's the first link below the video. Now back to the article. So, here is the theory of building long-running AI agents. Let's start with reliability. When agents have to be actually reliable while running for long periods of time, there are certain things you must do to contain the potential for compounding errors. At the core of reliability is context engineering. So in 2025, the AI models are already extremely intelligent, but just like with the smartest person, they cannot do their job effectively if you don't give them enough context. Now, hopefully you already know what prompt engineering is. It's the art of writing a task in the ideal format for an LLM. Context engineering is the next level of this. And it's effectively the number one job of us, people building AI agents, to master and to really nail down. So here is an example of an AI agent that's almost surely going to be unreliable. And this is very common, right? So there's a task coming in, the main agent breaks it down into subtasks, delegates it into sub-agents, and then they send the results to the main agent again, and it tries to combine the results. This is a tempting architecture. However, in production, this almost never works because it is very fragile. I think it's best if I just show you. So let me switch to cursor right here, and let me show you the first example of the unreliable multi-agent system. And by the way, all of this is available in the free GitHub repository, which I'm going to link below. You can take all of this code, you can look at it, what's wrong with these, and you can take the good ones and build your apps on top of them. I gave it MIT license, so you can literally do anything with it. And I also included a super simple setup guide, how to get it running on your own machine. So first, some essential imports. We set the model as GPT 4.1 mini, doesn't really matter. And then we load the API key, create the OpenAI client, some helper function, it's not really necessary. But here is the main AI agent, right? The task generation agent. So it generates the subtasks. The system prompt is return exactly 2 subtasks as JSON. Again, the prompt could be better, but the point is to demonstrate how the sub-agents work. And I think it's best if we just run this. So main task, design a new concept for a unique mobile game, right? So what does the main agent do? Creates 2 subtasks. First off, develop a storyline for the first agent. Second, create a visual style. We can already see where this might go wrong. Okay, so this is actually a perfect example. The first sub-agent says that it's in a vibrant, futuristic city, blah, blah, blah. Second sub-agent, because they run in parallel, right? The main agent breaks it down and these 2 run in parallel. They don't communicate between each other. So the second sub-agent is already talking about a dark, gritty tones for a horror game. Completely different than the first one. And then we're leaving it to the third agent to somehow combine these results. So as this article says, if your task is build a Flappy Bird clone, right? And you try to divide it into multiple agents, here's what might happen. Subtask number 1 would be build a moving game background with green pipes and hitboxes. Second subtask, going to the second sub-agent right here, would be build a bird that you can move up and down. The issue is that one agent might do a different visual style, build the environment in a way that is completely misaligned with the character and with the movements. And then the final agent can somehow put these together. And this can easily become a complete mess. So, principle 1 of building effective multi-agent systems is share context and share the full context, full agent traces, including what goes into them, what they do with it, and what goes out of them, not just the individual messages between the user and the assistant. So let's take a look at the second type of a multi-agent system, this time making sure each agent has the context of the previous agents. So this is a slight improvement, however, it is still not very reliable. So you have the main agent, which breaks down the task. Now really try to pay attention to these boxes, because these represent the context in the conversation, right? So the main agent receives the conversation and actions so far that happened before this point. Then it goes into 2 different sub-agents, right? Both of them have this context, so this is already a huge improvement from the previous workflow, but still they run in parallel, so they don't see what the other agent is doing, they don't see how it thinks, how it reasons, stuff like that. And then the third agent, once again, is left with combining this work. Even when it has all of the reasoning, this is still not a good solution. And here's why. When you give your agent the same Flappy Bird cloning task, this time you might end up with a bird and background with completely different visual styles. Sub-agent 1 and sub-agent 2 cannot see what the other was doing, and so their work ends up being inconsistent with each other. The actions sub-agent 1 took and the actions sub-agent 2 took were based on conflicting assumptions, not pre-described upfront. And here comes the second principle from this article. Actions carry implicit decisions, and conflicting decisions carry bad results. That's why Walden, the co-founder of Cognition and the author of this article, argues that principle 1 and 2 are so critical and so rarely worth violating that you should by default roll out any agent architectures that don't abide by them. You might think this is constraining, but there is actually a wide space of different architectures you could still explore for your agent. These ones are just some of the most popular ones, but unfortunately they do not really work in production. So what is an architecture that actually does work? Well, the simplest way to follow these principles is to just use a single threaded linear agent. That's why I named this repo Linear Agents. By the way, if you're finding this video valuable, please make sure to start this repository right here on GitHub. Just give it a star, that way more and more people can see it. Okay, so let's look at an example of a single-threaded linear agent that is simple and reliable. So a task comes in, goes to the main agent, you can call it manager, CEO, doesn't really matter. Again, pay attention to the context squares. It has all the conversation actions so far, same as last time. But instead of splitting it into parallel agents running at the same time, it first calls the first subagent with the full context. The first subagent does its work, adds this context. Then the second subagent is called with the original context. The first subagent works, so this is key. It knows what the conversation was before that. It knows what the first subagent did. And then it has complete awareness of the situation. And only then it begins its own task. And once it does its own task, it goes back to the main agent, which knows everything. Conversation, subagent 1, subagent 2, and it combines everything into a result. So let me show you what this might look like in code. This example is right here, simple and reliable. So again, we have the main task generation agent, creates 2 subtasks as last time, but instead of it being executed in parallel, right, we had async IO running these agents right here, running these agents in parallel at the same time. In number 3, we do not do that. We first run the first subagent, and then we run the second subagent, which now has the context from the first one. So it knows the task, it knows the user input, and it knows what the first agent did. And this is going to be much more reliable. So let me use the same prompt, design a new concept for a unique mobile game. Let me kill the terminal. Let's do a fresh. Boom. Main task, same exact prompt. Let's see. Okay, so we have this 2 subtasks, first subagent, and then it waited, second subagent, and boom. Let's see. Time canvas, right? Where players can rewind, pause, or fast forward specific objects independently. Layering multiple timelines to solve puzzles. So the second subagent, which again should create a visual art style, has created something that actually matches this idea. Why? Because it sees the response from the first subagent. And again, this is a very simple example, but no matter what you're building, choosing the right agent architecture is perhaps the most important decision. Because if you mess this up, trust me, and I'm saying this from lots of wasted hours on refactoring backend Python files for Vectel, you do not want to rush this decision at the start. Choosing the correct agent architecture and the correct layout of AI agents is perhaps the biggest decision you're going to make when building a multi-agent system. But again, don't listen to me. Even though I've built hundreds of AI agents and Vectel was used more than 50,000 people, I still have zero experience compared to the guys at Cognition. The team at Cognition is elite. It's multiple math Olympiad gold medalists, informatics Olympiads gold medalists. They have like a multi-billion-dollar valuation. They have some of the best AI agent builders in the world. They're the creators of Devin, which might be the most advanced and powerful agent in the world, right? So don't listen to me, listen to this article. And if you're going to do something, stick with this simple and reliable architecture. However, this is still not perfect because you might run into issues for very large tasks with many subparts where the context window starts to overflow. So this is how, this simple workflow might struggle with context overflow, because each agent needs to know what the previous agents did, and that can add up, especially if you're not using like GPT 4.1. Like in this example, I think we have 4.1 at the start. Even 4.1 mini, they have 1 million contexts, so you're probably going to be fine. But Claude models have 200K. That still lasts a long time, but you're going to overflow 5 times sooner than if you use like Gemini or GPT 4.1. But as the article says, to be honest, this simple architecture will get you very far. But for those of you who have truly long duration tasks and are willing to put in the effort, you can do even better. So here is an example of an AI agent architecture that is reliable on longer tasks, but it's a lot harder to get it right. So a task comes in, again, main agent breaks it down, but the key is that the conversation gets summarized. So you have context compression LLM running on the side that's compressing the context in real time. So the first agent doesn't get like a whole conversation, it gets compressed, maybe by 50%, maybe by 70%. Then the second agent gets the compressed conversation, but also compressed actions of the first agent. So only the key moments and decisions, nothing else. And same for the third agent, stuff like that. That way you can take, let's say, 100,000 tokens of context and narrow it down to the most essential 20,000, right? That way you can have much more longer running tasks, much more complex tasks, and your team of agents can run for way longer before you hit this limit of the context overflow that you might reach here faster if you're not compressing the context as you're delegating to more and more agents. So here's what that looks like in code. We have the example right here. It's this file right here, 04 reliable or longer tasks. So again, if you want to build an app with AI agents, feel free to just steal one of these, either number 3, which I would recommend for most of you, or number 4 if you really have advanced long-running workflows. But just take these and build on top of them. This is built on top of OpenRouter, so you can use any model. You can just swap out these models for Gemini, Claude, doesn't matter, with OpenRouter, super easy. Literally as trivial as changing the name. Like we can literally do it right that. You can do Anthropic / Claude 4. Sonnet. I think it's actually Claude Sonnet 4. Yeah, it's Claude Sonnet 4. This is the naming for Anthropic models. So you can literally swap this out super easy with OpenRouter. It's couldn't be any easier. So we have the task generation agent, and again, all the same stuff, but the context gets compressed. This is the key difference that the other 3 agent architectures didn't have. We have this compressor agent that actively summarizes the conversation to less than 200 words. That way it takes a lot longer until we run into any context issues. But there is a caveat. This is hard to get right. Don't think that you can just vibe code a solution to this. This problem, like multi-billion-dollar companies are struggling with this problem. And again, we're literally watching this invent in real time. I don't have the answer. Cognition doesn't have all the answers. Anthropic, OpenAI doesn't have the answer. People are trying to figure out what is the best way to do this. So don't think like you're just gonna vibe code it, like this meme on Twitter, or just vibe code a SaaS to 50K MRR and now your valuation of 3 million. Ridiculous. These people are complete clowns. It takes a lot of effort, a lot of thought to build an advanced multi-agent system that is reliable on complex tasks. That's why this article advocated for most people to stick with this simple and reliable architecture, which again works just as well as this more advanced one if you don't have that much context. Like if your AI agent doesn't need to go through a large code base, analyze dozens of files, like 15, 20 different files with hundreds of lines of code, you will probably never run into these issues. For most of the AI agents me and you guys are going to be building, we are going to be completely fine with this reliable and simple architecture that doesn't do any compression on the side. Because the moment you introduce this compression agent, again, it's complexity. Sometimes for advanced agents like Devin, this complexity is worth it because it needs to compress all that context. But if you don't need to do it, then go with the simple architecture. This is like a key business decision that no matter if you're in AI or in selling gardening, keep the business simple. Any part of the business that is complex, try to simplify it. This is like an essential principle that's going to save you tons of time. It's going to allow you to scale faster and hopefully save you a bunch of headache. So how do we apply these principles? First off, we need to ensure that your agent's every action is informed by the context of all relevant decisions made by other parts of the system. So don't try to hide any information. This is a terrible thing you can do. Make sure to give AI agents all context on what happened before. And if you need to summarize it, then compress it, but do not leave out any crucial info. As the article says, ideally, every action would just see everything else. So as you think about architecting your agents to avoid conflicting decision making, here are some other examples to think about. Claude Code subagents. So as of June 2025, Claude Code is an example of an agent that spawns subtask. Claude Code right now is perhaps the agent that I spent the most time with. It's absolutely amazing. I made multiple videos on it. Feel free to watch them again after you finish watching this one. However, it never does work in parallel. This is key. It never does work in parallel with the subtask agent. And the subtask agent is usually only tasked with answering a question, not writing any code. Why? The subtask agent lacks context from the main agent that would otherwise be needed to do anything beyond answering a well-defined question. So this is Anthropic themselves, right? Like it doesn't get more advanced than companies like Anthropic or OpenAI. They're literally creating these models. And they themselves do not do these advanced parallel asynchronous multi-agent architectures. They keep it simple. If they have a sub-agent, they just tell it, answer a specific question, right? Analyze the code base and give back answer to the main agent, and only the main agent writes the code. The main benefit of having a sub-agent in this case is that all the sub-agent's investigative work does not need to remain in the history of the main agent. So let's say you send a sub-agent to answer a very specific question like what package is the backend API using, right? It might analyze 5 different files and then come back with the answer. All of that analysis of those 5 different files would just be adding a bunch of noise to the main conversation history. So you would not append this. You would only get the answer for a very specific question for the sub-agent, which is returned to the main agent, and only the main agent does any actions, tool calling, or writes any code. The designers of Claude Code took a purposefully simple approach. And again, this is one of the best AI agents in the world right now. Claude Code is super powerful. People like myself are addicted to it, and it is a simple agent architecture. It doesn't do anything crazy, and it's a super powerful AI agent. Now here is one more powerful thought about multi-agents that's worth getting into. If we really want to get parallelism, aka, running multiple agents at the same time, out of our system, you might think, okay, so let's have them talk to each other and work things out, right? Why don't we just do that? Well, this is what humans do when we disagree, right? In an ideal world, sometimes it doesn't happen, but in an ideal world, if there's a disagreement, humans go back and forth, giving each other context, trying to figure it out, right? If engineers A code causes a merge conflict with engineer B, the correct protocol is to talk between each other to reach a consensus, to reach a mutual understanding. However, this is a big difference. This is why you shouldn't anthropomorphize agents. They are not humans. They are good at completely different things than people. Agents today are not quite able to engage in the style of long context, proactive discourse with much more reliability than you would get with a single agent. Humans are quite efficient at communicating our most important knowledge to one another. But this efficiency takes non-trivial intelligence. You have to know what to say, what the other person is thinking, stuff like that. Current LLMs do not have this skill. It is evident that in 2025, running multiple agents in collaboration only results in fragile systems. The decision-making ends up being too dispersed, and context isn't able to be shared thoroughly enough between the agents. So yeah, I was wrong. Previously, I also thought that multi-agent systems would work, and I showed it in a bunch of my videos, the potential of these, right? However, after months of building the agents in Vectel, I realized that multi-agent approach, while it looks tempting on paper, it's bad in practice. In theory, it sounds good. It sounds great, having these agents running at the same time, doing stuff. However, in practice, this breaks so fast, especially as you get into more complex tasks, and you run into so many issues that you wish you stuck with the simpler architecture. Now, if you have any ideas how to improve agent building principles or like novel ways to structure multi-agent systems, reach out to Walden, the author of this article, at this email, and who knows, maybe your idea will be used to make Devin even more powerful. Now, another thing that Cognition and Vectel have in common is that we're both trying to build an AI startup, which I do believe is the biggest opportunity in all of AI. After thousands of hours thinking about different AI opportunities, business models, what is the biggest opportunity, I came to the conclusion that building an AI startup is the best decision all of us can make. And the time to do that is right now. Thanks to tools like Devin, Claude Code, Cursor, Codex, anyone can build a $10,000 a month startup. Some people do it faster, some people will do it slower. But if you commit 40 minutes a day, you can do it. And I'm speaking from experience. Before Vectel, I've never built a startup before, and I certainly wasn't a professional developer. Yet I managed to use AI to go from zero to over $12,000 in monthly recurring revenue. And I documented all of that in the classroom of the New Society. And again, if you join the New Society during the month of July, you will get a month of Vectel Pro completely for free. So make sure to join. It's the first link below the video. With that being said, thank you guys for watching and have a wonderful, productive week. See ya.